Bag contains 3 black balls and 5 yellow balls. 2 balls are taken at random, one after the other without replacement. Find the probability that they are both. This question is similar to the one we just solved. We can solve it the way we solved the previous one, and we can also use tree diagram to solve it. So if we are using tree diagram, for the first draw, if both of them are black, remember there are 2 colors of ball here. So using a tree diagram, we have the first draw. One of the arm of this tree will be black, the other will be yellow. So let me put black here and the other one to be yellow because I have 3 black balls and 5 yellow balls, only 2 colors. So for the first draw, the probability of drawing a black is 3 over the total. The total is 3 plus 5, which is 8, the total. And the probability of drawing a yellow is 5 over 8. Then another arm again for the second draw. The second draw, if I draw a ball in the first instance and it happened to be a black ball, then the second draw, I don't have up to 3 black balls again, but 2 black balls. So 2, and the total number of balls is no longer 8, but 7. In this second draw, if I draw a ball and it happened to be a black ball, the number of yellows still remain 5. Number of yellows still remain 5, but the total number of balls is no longer 8, but 7. That is for the second draw. Then in this case, for second draw, this is black and this is yellow. So my number of black here still remain 3. Why is it 3? Because here is yellow ball that I'm drawing, but the total number of ball is no longer 8 but 7. That is for black. Why for yellow? Because I draw a yellow here in this first instance. The total number of yellow now is 4 and the total number of ball is 7. Let me explain this again. This arm is for yellow ball. So if I draw yellow ball here in this first draw, my number of black balls still remain, but the total number of balls is now 7 because I draw one yellow ball here. The yellow ball I draw, not black ball. That is why the number of black balls still remain as 3. But the total number of balls now decreases to 7 because of this draw here. And this draw here happens to be a yellow ball, right? So the total number of yellow balls now becomes 4. And all the ball, the total number of balls altogether is 7. So that is that. Using this tree diagram, now we can answer this question. This question says both are black. So we trace where do we have black in this arm. We trace the arm like this. This is black and this is black. So black is there. And black there, that is 3 over 8 times 2 over 7. So probability of black is 3 over 8 times 2 over 7. Let's reduce the fraction to make it easier. 3 times 1 is 3. 4 times 7 is 28. So 3 over 28. Then they are both yellow. Where we have both yellow is this last arm also. Look at this. We trace it like this, like this. So yellow and yellow. The last arm, which is 5 over 8 and 4 over 7. So probability, this is question A, question B. And both of them are yellow. We trace the arm. This is yellow. Is what? 5 over 8 times 4 over 7. 4 here 1, 4 here 2, which is 5 times 1 is 5, and 2 times 7, 14. 5 over 14. Then question 3, I'm using ABC, so what's the Roman numeral? Anyway, let me continue with ABC. So this is my A, this is my B, this is my C, D, and E. Question C says, the first is yellow, the second is black. So you trace where do you have yellow and black? This one is black. This one is black and yellow. This one is yellow and black. Okay, so this is the only place we have. The first is yellow, the second is black. That is 5 over 8 times 3 over 7. The probability that the first is yellow, the second is black is 5 over 8 times 3 over 7, which is 5 times 3 is 15, and 8 times 7, 56. 15 over 56. I don't think anything divide 15 and 56. And lastly, no, not lastly, that's question D now. It said one is yellow, the other is black. One is yellow, the other is black. One is yellow, the other is black. So that will be probability of since it's not specified whether first or second, this is yellow, this is black, or this and this. So it could be probability of this black and yellow or yellow and black. As this arm like this, black and yellow, which is 3 over 8, 5 over 7, that is this arm. Or this one that is yellow and black, that is 5 over 8 again, 3 over 7. So that would be, what is it? Black and yellow, 3 over 8 times 5 over 7. Oh no, NEPA. The NEPA, my inverter, not recognized. Let me be. So black and yellow, we're talking about this now. Right, 3 over 8 and 5 over 7. 5 over 7, all means addition or probability. As plus yellow and black, that is 5 over 8 times 3 over 7. What is wrong with this thing? Okay, so this will be 3 times 5 is 15. 15 over 8 times 7, 356 56 plus 15 over 56 again, which is 30 over 56. 30, 2 in 30, 15. 2 in here is 28. So 15 over 28. And finally, they are of the same color. They are of the same color. Where and where do we have the same color? We have black, black here. And then we have yellow, yellow here. So they have the same color with the probability of black, black or probability of yellow, yellow. That is a question E, right? Yeah, question E. Probability of same color is equal to probability of black, black or probability of yellow, yellow. And probability of black, black and black is 3 over 8 times 2 over 7. Or means addition of probability. Then probability of yellow, yellow. Yellow, yellow is 5 over 8 and 3 over 7. No, 5 over 8 and 4 over 7. 5 over 8 and 4 over 7. 5 over 8 and 4 over 7, which is 3 times 2 is 6. 8 times 7, 56, plus, let's reduce this, 4 here 1, 4 here 2, so 5 over 2 times is 14. LCM of 56 and 14 is 56 itself. 56 divided by 56 is 1. So 1 plus 56 divided 14, 4. 4 times 5, 20. 6 plus 20 is 26. So 26 over 56. 2 here 13. 2 here 28. 13 over 28.